Using Snap Tutorial. Standalone Tool Adapter with Bundle. This tutorial was created for External Tools module of Snap. Before integrating an external tool in Snap, you must know how to execute the tool from command line. The command line arguments must be remembered in order to integrate the tool in Snap. Integrating a tool in Snap means that Snap will create a new process to execute the tool after the user inputs the desired parameters in the graphic interface of Snap. If configured, the progress of the tool is visible in Snap. For this tutorial, the Orfeo toolbox band math processor was adapted in Snap. For further details, please check the Snap help topic for the standalone tool adapter. Open the Snap application, go to the menu Help, submenu Help Contents. In the Search tab of the Help window, type Standalone Tool Adapter. Next, go to the menu Tools, submenu Manage External Tools. The External Tools form lists all the currently adapters, and a list of actions for creating a new adapter, duplicating an existing adapter, editing, deleting and executing an adapter. For creating a new adapter, click on the button New. The form for creating a new adapter is opened. This form contains tabs for Operator General Information, Configuration, Preprocessing, Parameters, Variables and Bundled Binaries. The first tab, Operator Descriptor, contains multiple fields. Alias is a short name for the adapter. Unique name is a name which registers the adapter in the toolbox. It must be unique among all adapters. Label is the user-friendly name. Version is the version number input by the user. Copyright, authors and description are optional. Menu location is the path in the Snap menu where the tool shortcut will be placed. The tool action can be placed in one of the existing menus, or create a new menu. In the System Variables tab, there are two types of variables. Simple variable, that only have one value, and platform-dependent variable. This variable allows setting values for 3 supported operating systems: Windows, Linux and Mac. For the example of band math processor, multiple variables should be configured. First, add a platform-dependent variable. This variable is necessary when creating a single adapter for a tool that can be used on either operating system, but the extensions are different among the systems. BAT on Windows, and SH on Linux and Mac. Next, 2 simple variables should be added: the path to the tool executable, and the path to the output directory. For now, we will leave the tool executable path empty. Shared variables are helpful for more adapters who use the same variable. Modifying the value in one of the adapters, it will be automatically reflected in the other adapters. Usually, another variable is useful when defining adapters that will need to work on other machines. In this case, the locations will need to exist on any machine. To handle this request, a platform-dependent variable can be added, naming it user profile, that for Windows will take the value of the system variable with the same name, and for Linux and Mac will have the value tilde. On the tab, Operator Parameters, each parameter can have 5 properties: name, description, label, data type and default value. By default, the adapter have 3 parameters that cannot be deleted or edited. Source product represents a list of products chosen from the ones loaded in Snap at the execution time. Source product file is a file or a list of files from where the selected source products were loaded. Target product file is a file corresponding to the target product that will be loaded after the tool execution. For adding a regular parameter, click on New Parameter and set its properties: name, description, label, data type, default value. More fields for this parameter can be edited by pressing the corresponding ellipsis. If the parameter is a template parameter, the editing form looks different and allows the user to choose the template file. For further details about template parameters, see the Help. Then, the Preprocessing tab contains 2 fields: For executing an already defined tool, with the same input parameters values as the current tool, check Preprocessing tool and choose in the combo box the desired tool. If before processing convert to is checked and a writer is selected, the product is written to disk as the second step of the adapter's pre-execution. In the presented case, the bandmath processor knows how to handle only TIFF files, so it is necessary to write the input product by using the GeoTIFF writer before executing the processor. Next, the tool binary can be added in the adapter. This is useful when distributing the adapter together with the tool itself. The adapter will handle the download and the installation of the tool. The 3 operating systems supported by the adapter must have separate bundles defined. For each operating system, the following must be provided. The type of the bundle can be zip archive and installer. The accepted installer format is a self-extracting archive. The location of the bundle can be local, on the machine where the adapter will run, or remote, on a website, for example. The source file or the URL of the bundle, depending if it is local or remote. The arguments are used to extract or install the file. Can be used, for example, when installing self-extracting archives, when the output location must be given as argument. The target folder is the location where the bundle is extracted or installed. The variable to reflect the installation location must be an already existing variable defined in the previous steps. In this example, the OTB archive will be downloaded from the OTB site, and the URL must be filled in. The installation folder will use the user profile variable defined earlier. The variable to hold the installation location will be the one defined earlier, that was left empty, OTB bin path. The download and install button should appear after filling all the fields. If not, it means the values are not valid. The bundle can be installed when defining the adapter, or later when editing the adapter, by pressing the installation button. A progress bar will be visible and a confirmation message will be available when the download and installation finishes. After installation, the variable holding the installation path will have his value filled in. The last tab can be configured, configuration parameters. Tool executable represents the location of the executable file. There are 3 ways to express the location. The first situation is when the executable is added to system path. In this case is enough to set the executable name and extension. The second way is to put the full path to the executable together with the name and extension. In this tutorial, the third form is used to express the path by means of one of the defined system variables, together with the executable name and extension. Working directory is the place where the temporary files are saved. If the option, tool produces the name of the output product, is selected, the user will not be able to select the name and the location of the output product. Still, Snap will be able to open the product. At the beginning to this tutorial, the tool was executed with the command line. In section command line template, each command line arguments will be written on a separate line, using the system variables if necessary. Tool output patterns includes 2 defined regular expression patterns for determining the progress of the tool and the error status. When all the parameters are set, click OK. Open an input product in Snap and run the tool. There are 2 ways to execute the tool from external tools by selecting the tool and click Run, or from the configured location in the menu. In the first tab IO parameters, choose the source product as the product that was just opened. The processor creates a new output product, having the name derived from the original product, with processed added at the end. The name can be changed as desired. The output can be saved on disk by checking the option Save As and choosing a product writer from the list. In this case, the directory where the output will be saved should be chosen. Next, in Processing Parameters tab select Display Execution Output, and for each input parameter change the value as desired. Then click Run. When the process is finished, Open the output product and check the bands. In this case, the resulting band should correspond to the mathematical expression given by parameter. Thank you for watching.